Hey guys, welcome to my channel. Today, we'll look at how mechanical component inside a split AC work to cool and condition the air. Let's dive in. A split AC has an indoor unit and an outdoor unit. In the outdoor unit, we have a compressor, condenser and axial flow fan. The cycle starts with compression of the refrigerant in the compressor. Many types of compressors are available for gas compression, but generally scroll compressors are used for small to medium scale cooling applications. They are quieter, smoother, efficient, and have long lifespan and require minimum maintenance. Two identical scrolls are used for refrigerant compression. One is fixed and the other orbits around it. It is important to note that the motion of the moving scroll is completely orbiting with no rotation at all. For clarity, watch this. Can you tell the type of motion of these circles? The left circle had only orbital motion, but the right circle had the orbital as well as rotational motion. It is because the point on the circumference of the left circle maintained its angular position with respect to its center. However, the point on the right circle completed one trip around the center of the circle. As a quick fact, the motion of the Moon around the Earth is also orbital plus rotational motion. The time taken by the Moon to complete one orbit around the Earth is equal to the time it takes to rotate once about its own axis. So, the people on the Earth can only see one side of the Moon. Now see, refrigerant enters from this port and fills the available space. As the scroll moves, the refrigerant gets trapped and progressively reduced in volume. The top of the spirals is covered with another plate which has a small opening. That small opening is closed with a cap which provides sealing. Above the cap, there is a spring. On reaching the center of the scrolls, the pressure of that fixed mass of refrigerant becomes very high. Thus pushes the small lid above, and escapes the compression area. As the high pressure gas escapes, the lid is pushed back in place by the spring-loaded mechanism. The whole assembly is enclosed in a casing. The highly compressed gas escapes the compressor and enters the condenser tubes. As the name suggests, the condenser has to condense the refrigerant gas into a liquid. For that, the hot pressurized gas must be cooled down. A fan blows air over the tubes to cool the inside gas. To extract more heat from the gas, fins are attached. The air thrown by the condenser fan gets hot. However, the gas temperature is decreased, and it becomes pressurized liquid as it exits the condenser tubes. There is an expansion valve before the evaporator. Its purpose is to expand the liquefied refrigerant into mist, where it enters the evaporator coils. According to Joule-Thomson effect, when a high-pressure fluid is allowed to escape from a very small opening, it cools down. There the temperature goes down to 0 degrees centigrade. A cross-flow fan flows room inside air, over the cold tubes. It is important to note that no outside air enters the room. As the inside room air gets in contact with cold tubes, it gets cooled. Thin metal fins are attached, so that air releases more of its heat energy to the refrigerant, by making contact with large cold area. During air cooling, water content in the air gets condensed on evaporator. It is because the temperature of the evaporator coils is very low, as discussed earlier. You must have witnessed this phenomena on cold water bottles. The gaseous water in the air releases its heat energy to the cold water, and gets condensed in liquid form. On leaving the evaporator, the refrigerant enters the compressor, again in gaseous form. To prevent any liquid particle from entering the compressor, an accumulator is placed between evaporator exit and compressor inlet. If you found this video useful, and would like to watch more related videos, please support me by subscribing and sharing. Thank you so much for your motivating comments.